Okay, ready? Hello, my name is Nicholas Takach. I'm a professor of chemistry at the University of Tulsa, Oklahoma. And I'm going to do a demo today that sort of used to be done as a magic trick. So it is magic in a way, forgot that, because I'm going to lift this piece of wood without touching it. So, did I get the stirring jar out? So this is very unprofessional. Sorry, but you know I'm just a scientist, even though I'm superstitious. Okay, here's a piece of wood. So what I'm going to do is I'm going to squirt water on the wood. Then I'm going to put this beaker on top of it, and I'm going to lift the wood without touching it into the air. And it won't be because of surface tension. That was the control experiment to show you surface tension is an interesting force, but not nearly strong enough to do that. So I have a magic wand. This is going to be magic. I'll use the magic wand later as well in the next demo. But for now, I'm going to take this chemical, and this gives me a chance to use the word hygroscopic. You know what hygroscopic means? It tends to absorb water. And so that makes this chemical was crusty and had a big clump in it. So I was already worried that that was going to cause problems. But that wasn't the problem when I tried this earlier today. Here's another chemical. I'm not going to identify what these chemicals are. And a magician never explains his magic. So if this video makes it to YouTube, hope so, you have to send me an email and I'll explain the chemistry. Before I forget, let me give credit to where this demo came from. This is an American Chemical Society publication. You can see the title, I believe. You can read the title yourselves. And there's 3 volumes of this. I've got all 3. Okay, so here comes the second chemical. And what I'm going to ask Miranda to do, also want to give credit to the videographer, Ethan. So we'll do a title slide here later on. First, I'm going to make sure that there's still plenty of water here. Okay, now, Miranda, have you ever seen a chemical reaction involving 2 solids before?
I'm sure.
Have you? Just 2 solids? Who's seen a reaction like that? Anywhere?
Magic.
Yes. Okay, but look at what happens with time. It's going to change appearance. At first it was 2 crystalline solids, right? And now you should be able to see some changes. And you should be able to smell something. Get closer. Don't get your nose right next to the beaker or you might pass out. It might knock you on the floor. You smell anything?
I don't.
No. Okay, look at what's happening in the beaker now. What's happening?
It's dissolving or turning.
It's turning into a slush. How did that happen? Like I said, if you want to know, you have to send me an email. I'll explain it all. And of course, to the class here, I'll explain it next time we meet. But Ethan told me, I asked students if anyone had experience uploading videos to YouTube, and he said he had a lot of experience. The name of the demo might be a clue. It's endothermic reaction of two solids. Ta-da! It worked. If at first you don't succeed, try again. This failed in the morning class, but it sure as heck is working now. And with that, I'm going to ask Ethan to end the video. You can see my email address. This will make it to YouTube. I don't know how many views it's going to get, but did you ever swim anything?